This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, I want to take a look at the concept of similar triangles. Now, you might remember something that you looked at before, which was congruent triangles. Congruent triangles, which had all sides and all angles equal. But in the case of similar triangles, also called equiangular triangles, all three angles in one triangle have the same measurement as the corresponding three angles in the other triangle, but, and this is the key point, while the angles might be the same, so in this triangle ABC, we have angles of 50 degrees, 60 degrees, and 70 degrees, and in this triangle DEF, we have the same angles, but the lengths are different sizes. And that's the crucial difference between congruent triangles and similar triangles. In congruent triangles, all sides and all angles have to be equal, but in this case, we're only looking at the angles being the same, so the sides could be different lengths. So a theorem for similar triangles is that the corresponding sides of similar triangles are in the same ratio. So if we have two triangles, ABC and DEF, and we have that their corresponding angles are equal, so in my case here, my angle at C is the same as my angle at F, my angle at B is the same as my angle at E, and my angle at A is the same as my angle at D. Once I have similar triangles, then the lengths of the sides of the triangles will be in ratio. So if we look at our bigger triangle, the length AB between this angle and this angle is going to be in ratio with the length between those two same angles here, so the length DE, so these two blue sides will be in ratio. So AB over DE is one ratio, but what can we set that equal to? Well, we can set it equal to the same ratio for another pair of sides, so these red sides here between this angle and this angle, so corresponding here, so we can write BC over EF is also equal to AB over DE, and our third side pair, AC over DF, will also be equal. And lastly, we can just invert those three relationships. So instead of doing this larger side over this smaller one, we can do the smaller one over the larger one either. So DE over AB is equal to DF over AC is equal to EF over BC, which is what we have